All right, guys, what we're going to look at today is how to simplify a complex series parallel circuit and do all the calculations associated with that circuit. Okay, here's our initial circuit right here. You've got 7 different resistors. Pay more attention right now to the orange part of the drawing and the purple part of the drawing. Okay, so we've got our circuit here. We've got all of our resistors labeled, okay? And for our first step, what we always want to do is, here's our supply. We want to start simplifying at the furthest point away from the supply, okay? So we're going to start simplifying at R6 and R7, all right? Now, if we look at our first step for simplification here, what we've done is we've taken and combined R6 and R7, okay, since they're in series, it's just simply R6 plus R7 to get that combined resistance right there. And this is what this green RC1 is. This is combined resistance 1, okay? So it's going to make it much easier for you to follow by simply putting that into the formula as we go, okay? So R6 plus R7 here is going to simplify that branch C, okay? And it is going to add up to 1.68 kilo ohms. So RC1 here is 1.68 kilo ohms. Number 2, what we're going to do next is R5 here is in parallel with R6 and R7, which are in series with one another, okay? So what we're going to do is we're going to take R5 and put it in parallel with this combined resistance 1. Okay? So there's R5 in parallel with combined resistance 1. And when you look at the value of R5 as 560 and combined resistance 1 value of 1.68 kilo ohms, you put those together, that's 1 over RT equals 1 over R1 plus 1 over R2, okay? We've done that already. So when we make that combination comes out to 420 ohms. There it is right there as RC2, and that's what we're going to call it for right now, is combined resistance 2. And that value is 420 ohms. Now, we move over here to step 3, okay? If we look back here, we've got R4 in series with combined resistance 2. All right? So what we're going to do here is we are going to add that R4 to that combined resistance value 2. Now, if we look here, that R4 is 470 ohms. RC2 is 420 ohms. So we add those together and we come up with 890 ohms. And that is the value right here of R4 plus RC2, which is combined resistance 3. Okay? So RC3 right here has a value of 890 ohms. Our next step, step 4. We're going to leave RC3 alone for right now, because when we look at our circuit coming back toward the supply, we've got a couple of resistors that are in series, but they're in parallel with RC3. So what we need to do first is we need to combine these 2 resistors here to take care of that. So what we're going to do is we're going to take R2 plus R3, okay, those 2 resistors, and we're going to combine those in series as one resistance value. Okay, and we're going to label that as RC4. That RC4 value is 270 ohms plus 330 ohms. Okay, that's going to give us 600 ohms. There's our RC4. There's our value of 600 ohms. Okay, now moving forward to step 5. Now we come back and we look at taking RC3 into consideration and RC4. So here's our RC3 right here. And here's our RC4. Those are in parallel with one another. So what we're going to do is we're going to take RC3 and put it in parallel with RC4. Okay, again, 1 over RC3 plus 1 over RC4. Okay, and we're going to be able to calculate that out. And that's going to be 358.39 ohms. and we're going to call that RC5 right here. Okay, so if you look so far, we've moved through these steps. Okay, we're here. We've got RC5 that we've created. Okay, and that is in series with R1. Now, we know that R1 is 150 ohms. So we're just going to simply add R1 plus our RC5 value of 358.39 ohms. We're going to come out with a resistance value of 508.39 ohms. Now, that is going to be our total resistance value for the circuit. Okay? Now, we have gone through all of this just to calculate the total resistance of the circuit. Now, we have the total resistance. Well, we know that our source voltage here is 17 volts. Well, we just move that down here to simplify things so that we can see it. And we've got a single resistor circuit that we've simplified to, okay? RT of 508.39 and a source voltage of 17 volts. Well, we know that 17 volts is going to be across that. So we take 17 volts divided by 508.39 ohms, okay? That gives us our current. Well, since we've done this for total resistance, this is actually our total current value of 33.44 milliamps. Okay? So now we have calculated everything we can at that point. We've gotten our total resistance value and we've gotten our total current value. So now what we have to do is we have to start working ourselves back in reverse towards the original schematic. Okay? Now, bear with me here, and if you need to, stop the video every now and then to kind of take notes or do whatever you need to do. But we're starting right here at number 6, working our way back, okay, all the way to the very beginning. So, we've got 17 volts, okay, 33.44 milliamps, and a total resistance of 508.39 ohms. So, if we move back to step 5 here, okay, when we start expanding the circuit back out, we see that this resistive value, RC5, is of course in series with R1. Well, what do we know about series circuits? We know that the current is the same in series circuits. So, if we've got a total of 33.44 milliamps, okay, and all we're doing is breaking out two resistor values in series, we know that that current is going to remain the same with those two resistive values, okay? So, we know that there's going to be 33.44 milliamps through RC5, and there's going to be 33.44 milliamps through R1. So, we have our value of 150 ohms for R1, our value of 358.39 for RC5, and what we can do now is we can calculate the voltage drop across those two resistors. Okay? So, 33.44 milliamps times 150 ohms, we come up with 5.02 volts. So we have now found the voltage drop across R1. If we look here at RC5, 33.44 milliamps, we've got 358.39 ohms. We multiply those together and we get 11.97 volts. Now, what I want you to think about here, and think about this as you move back through. Use your common sense and look at this. So, we had a total of 17 volts here. We know that series circuits are voltage dividers. We've got 5.02 volts there, 11.97 volts there. That comes up to a calculated value of 16.99 volts. What is our source voltage? 17 volts. Okay? That's a good enough calculation that gets us very, very close. Now, the reason that's off a little bit, of course, is because I did a little bit of rounding. So, we've got our voltage drop across here. We've got our current flow through there. We've got our voltage drop across here, and we've got our current flow through there. So, now we're going to move back to step 4. Well, what are we doing in step 4? We're taking this RC5 resistive value, and we are expanding that back out into this RC4 resistive value and this RC3 resistive value. Do you see that there? So, we'll work with RC4 first. All right? We have done what? We have taken one resistive value and split it in parallel. What's the same in parallel? Voltage is the same in parallel. So, we know that we're going to have 11.97 volts across RC4 and 11.97 volts across RC3. So we've got our given values that we need, okay? Now, we've got a voltage value there and we've got a resistive value of 600 ohms. Now, 11.97 divided by 600 ohms, that's going to give us 19.95 milliamps. Okay? So, with that 19.95 milliamps, I know that that's going to be flowing through this entire branch right here. Okay? 19.95 milliamps is going through branch A. Now, if we look back here at step 3, we do the very similar thing. You've got your resistive value, okay? You divide your voltage by your resistor value. Same thing here, 11.97 volts divided by 890 ohms. That's going to give us 13.45 milliamps. Now, if we add 13.45 and 19.95 milliamps, we're going to come up with something very, very close to 33.44 milliamps. Parallel circuits are current dividers. Okay, voltage is the same, but they are current dividers. So these two currents should add up to that previous current. Again, think about this logically. Make sure that your calculations make sense. So we've got 19.95 milliamps here, 13.45 milliamps there. Okay, we figured out everything we can here, and we've begun on this step 3 here. Okay, so in this step 3, if we look, we've broken out this RC4 back into two of the original resistors that are in series with one another. What do we know about series? Of course, the current is going to be the same in series. So through R2 and through R3, we are going to have 19.95 milliamps flowing through both of those resistors. Well, if we know that, we also know our original resistor values. So what we do is we multiply, of course, that 19.95 milliamps times the resistive value, 270 ohms, 19.95 milliamps times 330 ohms. That's going to give us the voltage drop across those two resistors. Again, voltage divider in series. None of that changes. So we've got a voltage across 3 here that's going to be 6.58 volts. We've got a voltage across 2 here that's going to be 5.39 volts. Again, if we add these two voltages together, they should come up to that 11.97 volt value. Okay? So, we talked earlier, just a second ago, about that RC3 value, and there's nothing crazy there. It's at 11.97 volts divided by 890 ohms. We get that 13.45 milliamps. Okay? So we found out everything that we possibly can so far in step 3. Now, working our way back down to step 2 here. Okay, what have we done in step 2? We've taken that RC3 value, okay, and we've broken that up into those R4 and RC2 resistors. Since we've done that, we know that these two resistors are in series with one another. Well, if they're in series with one another, what's going to be the same? Your current. Once we've broken this back apart here, okay, we know that we have 13.45 milliamps flowing through that branch. So I've got my 420 ohms, multiply that by 13.45 milliamps, and you should come up with about 5.65 volts for the voltage drop across this RC2 value. All right? Now, if we take a look, okay, at R4, okay, R4 is in series with RC2. Well, if we look down here, our R4 value is 470 ohms. We know that since these are in series, it also will have 13.45 milliamps flowing through it. And we multiply those together, and we come up with 6.32 volts. Okay? So, that gives us our voltage drop across R4. We've got our current flow through R4, and we already had our resistive value for R4. So we've done everything we can for R4. So far, we've completed everything for R1, okay, R2, R3, and now R4. Now we're going to go back to this step 1 here, okay? And what are we going to do? We're going to take that RC2 value and we're going to break it apart into our RC1 value and then our R5 that's in parallel with RC1, okay? So when we do that, when we break it apart in parallel, what do we know is going to stay the same? That's right, voltage. So we've got a voltage value here on RC2 of 5.65 volts. That means that across R5, we are going to have 5.65 volts. Across RC1, 5.65 volts. So if I know that, I can do a quick calculation. Volts divided by resistance, so 5.65 volts divided by 560 ohms, and that's going to give me my current flow through that branch. Okay, so I'm going to have a current flow through I5 that's 10.09 milliamps. All right, now moving to RC1 here. We've got an RC1 value of 1.68 kiloohms. We've got a voltage across both of these that is 5.65 volts. 5.65 volts divided by 1.68 kiloohms, that is going to give me 3.36 milliamps flowing through branch C. All right? So, we go from step 1 here back to our original schematic. What have we done? We've taken RC1 here and we've broken it out into R6 and R7 that are in series with one another. Because they're in series, we know that that 3.36 milliamp value of current is going to be flowing through R6 and R7. So we've got that given value, and then the value of the resistors. So we multiply for R6, 3.36 milliamps times 680 ohms. That is going to give us our voltage drop across R6. That is going to give us 2.29 volts. The same multiplication right there, it's going to give us our voltage drop across R7 is going to be 3.36 volts. So what we've done here is we've taken a very complex circuit, we have simplified it all the way down to a single resistor. We found our total resistance value and we found our total current value. Then we started expanding it back out into towards its original form and finding all of the other values along the way. So I hope this helps you guys out. We'll be doing these in lab for quite some time now, and so please comment or give me some feedback in class and let me know if this video helped you out. Thank you. Hope you guys have a great day.